what to do to avoid the Wendt's disease? Got it? You click on got it. What to do to avoid the Wendt's disease?
Sir, to avoid the bench disease, sir, so the air that that is given to the this diverse consists of a mixture of gases, the air diluted with helium, 11.7% helium, 56.2% nitrogen, and 32.1% oxygen.
Okay, very good, very good. So now you see the sharing. I am doing the sharing here. A slide little bit we are sharing here. Let me check the slides here. Just 1 minute. Just 2.6. Is this slide is visible to you?
Yes, sir, visible.
Okay. So here if you see, that is vapor pressure of liquid solution. We are going to cover this one. This is vapor pressure of liquid solution. Okay. Vapor pressure of liquid solution, or the vapor pressure of the liquid solution. So what is the vapor pressure? If you talk about the vapor pressure, that is we are cover gas in liquid, we have covered already. So we are going to study the liquid into liquid. Liquid solutions means liquid in liquid. So what is there here, Sanoy? If you see, this is there. This is the liquid surface. This is what is the liquid surface. Okay. So liquid surface. So when the gas is all liquid are volatile. All liquids are volatile. All liquids are what they are saying volatile. Okay, volatile. Some may be more, some may be less. All liquids are volatile. That is they have vapor pressure. They have vapor pressure. Okay, vapor pressure. That is, now we have to know that is what is the vapor pressure. So liquid particles, some of the liquid particle, what they are going to be, they are going to convert into what? They are going to convert into vapors. Suppose these are the vapors of the liquid. Getting, these are the vapors of the liquid. So these particles, when they are jump, they are going to exert pressure on the surface. They are going to exert pressure on the surface. And this is this whatever the pressure they are exerting on the surface, that is called the vapor pressure. Okay, that is vapor pressure. That is one thing you keep in mind, that vapor pressure is what? That is the pressure exerted by vapors of the liquid over the liquid surface is called vapor pressure. Now here you see liquid solution are formed when solvent is liquid. Solute can be solid, liquid, gas, whatever, but the solvent is must be liquid. The solute can be a gas, liquid or solid. Solution of the gases in liquid are already been discussed in the section. That one we have discussed in the Henry law. In this section, we shall discuss the solution of liquid and solid in liquid. What they are saying? Solution of liquid and solid in liquid. So we are talking about liquid. Firstly, we are liquid, then the solid in liquid. Such solution may contain one or more volatile component. What is volatile component? That have vapor pressure. Okay. Generally, the liquid solvent is volatile. Already they are saying liquid solvent is volatile. The solute may or may not be volatile. We shall discuss the properties of only binary solution. That is the solution containing two components, namely the solution 1. Solution 1, they are saying liquid in liquid. And second one, solid in liquid.
Sir, give me 1 minute time, sir. I will turn on this mosquito, this liquidizer, otherwise mosquito is biting.
Okay. You turn on. Okay. Done. Done. Now see the vapor pressure of the liquid solution. Vapor pressure of liquid solution. So let us read the NCERT so that you will be able to understand much better way. Let us consider a binary solution of two volatile liquid. Which liquid? Two volatile liquid. Denotes the component 1 and 2. When we taken in the closed vessel, both the component would evaporate. Eventually, an equilibrium would be established between the vapor phase and liquid phase. Where the equilibrium is established, Sanoy? Where the equilibrium is established? This is the liquid, and here these are the vapors. These are the vapors. Liquid and vapor. Here will be the equilibrium is going to establish between the two component. Is it okay up to here?
Yes, sir.
Now,
Okay.
let the total vapor pressure at this stage be P total. So what they are saying? P total. So P total will be sum of P1 plus P2. So they are saying and P1, P2 be the partial pressure of vapor pressure of two component 1 and 2. P1 is the vapor pressure of 1 and P2 is vapor pressure of 2. P1 is solute, then P2 is solvent, respectively. These partial pressure are related to mole fraction x1 and x2 to the component 1 and 2 respectively. So how they are saying this partial pressure will be related to P1 is equal to P1 not x1 and P2 equal to P2 not x2. Means that is P1 proportional to x1 and P2 proportional to x2. So when we are removing the proportionality sign, this is coming. Okay, they are saying that is P1, here they are, these partial pressure are related to mole fraction x1, x2. Here you see French chemist, what is? Francois Marty Raoult gave the quantitative relationship between, quantitative relationship is known as Raoult's law, which state that, now here the Raoult's law is starting. Okay, from here. For a solution of volatile liquid, the partial vapor pressure of each component of the solution is directly proportional to mole fraction of the solution. This is partial pressure of each component is proportional to mole fraction of solution. So if it is solvent, so it's a mole fraction. It is solute, that's mole fraction. Getting this?
Yes, sir.
Now, if you remove the proportionality sign, so it will come P1 is equal to P1 not x1, P2 is equal to P2 not x2. Now, little bit you read more. Thus, for component 1, P1 proportional x1, P1 is equal to P1 not x1. Okay. Now, go little bit down. P1 is the vapor pressure of pure component 1 at the same temperature. Pure component. See, two things are there here. If I will go P1 is equal to P1 not X1. Okay. So this is the mole fraction in solution. Mole fraction of A of 1 in solution. In solution. What is P1 not? Vapor
Even
pressure in pure state. Pure state. Pure state means when it is not, when it is alone. And this is the partial pressure. This is what partial pressure. Partial pressure of 1 in solution. Are you getting this one? This is the pure state. Last day what we study in the Henry law, P1 is equal to KHX1. So here this is replaced. KH become what? Vapor pressure in pure state. This is the proportionality sign. For the liquid, it is the P1 naught. For the gas, it is KH. Now you see for P2, it will be P2 naught. What will be there? P2 is equal to P2 naught X2. P2 naught represent the vapor pressure in pure state. Is it okay?
yes, sir.
P total is equal to P1 naught, P1 plus P2. Now you put the value of the P total. P1 naught X1 and P2 naught X2. Is it okay?
Yes, sir.
What is there? So once more you try to understand. PT is equal to P1 plus P2. So P1 is what is there? P1 not X1 plus
Even
P2
PT
not.
means the total one.
What?
PT means the total one.
PT is total pressure of the solute and solvent. Now you see this is the PT. You can calculate by this equation by using this equation. This is the Raoult's law only. Raoult's law. Raoult's law. Okay. Now this the Raoult's law is saying that is we can total pressure can be related to any of the mole fraction. If you get to know the mole fraction of any of the component, so vapor pressure we can correlate. See, since we know P1, no, x1 plus x2 will be how much, Sanoy? X1 plus x2. how much it can be? Sum of mole fraction, how much?
1.
1. So x1 is equal to 1 minus x2. Can we write?
Yes, sir.
This equation is 1. This equation is 2. So from 1 and 2. From 1 and 2. So from 1 and 2, what we can write? Pt equal to P1 naught. In bracket x1 value, 1 minus x2 plus P2 naught x2. P2 naught x2. Now, little bit solve it. This is the, if you simplify this one, Pt is equal to P1 naught minus P1 naught x2 plus P2 naught x2. P2 naught x2. Now, see little bit bottom here you see Pt is equal to, no, this we are correlating. How much? We are rearranging positive first, then negative. P2 naught x2 minus P1 naught x2. So what is there? P1 naught here you can see this was positive time x2 minus, here x2 is common. Is it common? X2 is common.
Right.
X2 is common here. So let us see this one. X2 is common. So this is P2 naught minus P1 naught. Outside what will be there? This will be X2. This is the, so this is related to the mole fraction of solute. Here you can see P1 naught. This is the PT. P1 naught equal to P2 naught minus P1 naught is equal to X2. But this formula you can use here. Here itself you can use for numerical. For derivation purpose, this is okay.
Yes, sir.
Now, this is the Raoult's law. Raoult's law, what they are saying? Vapor pressure of liquid is proportional to its mole fraction in solution. Vapor pressure of volatile liquid is proportional to mole fraction of the component in solution. What the conclusion can you draw from it? The vapor pressure can be dependent on any one of the mole fraction, because in this equation only one mole fraction is there now. So here they are saying total vapor pressure over the solution can be related to the mole fraction of any one component, any one. Here we have considered x1 is equal to 1 minus x2 now. So x2 equal to also you can consider 1 minus x1.
Anyone will to choose and use that.
Anyone, either solute or solvent. Here suppose this is what? This is the solute. Now, this is solute. Now, if you are confusing, let me tell you one thing, another thing. Pt is equal to P1 naught x1 plus P2 naught x2. P2 naught x2. This is equation 1. So here you see what we can write, that you know now x1 plus x2 is equal to 1. So x2 is equal to 1 minus x1. Yes, yeah, no, this is 2. So from 1 and 2, from 1 and 2. So what is Pt is equal to P1 naught x1 plus P2 naught, here is x2 value 1 minus x1. Here you see, Sanoy, P1 naught x1 plus P2 naught minus P2 naught. It will be P2 naught x1. Yes or no? So here you rearrange this one. P2 naught, let it be like that, plus P1 naught x1 minus P2 naught x2. Is it correct? Okay. Are you getting sleep? P2 naught,
No,
here you see. Here somewhere we are doing mistake here. We are plugging the value of this one. So this is P2. This is the P2. If you are solving this one, so here is P1x.
it will come like this. What it
Uh,
is.
that will not come like this, na? Hmm. Common is
P-
common. We are not getting anything.
So we
X.
are getting 1 minus x1. So here p1 not x1 plus p2 not x1. No, answer.
Hmm. Where is the common in this factor?
minus this one, sir, P2 not X1. This
Hmm.
one.
Hmm.
Now P2 not plus
Hmm.
X1.
This is P2 only, na? Here, this is P2, na? This is P2, na?
Yes, sir.
Ah, sorry, na? This is P2, not
No,
P2.
no,
This is
no. This is
P1.
P1 only. This is
Ah,
P2.
ah.
So this way we will take the X common, na? So sir, here one X is also there, here one X is there. This will be
This is
X1, sir. But in
this
that
X1,
way.
na? X1,
Ah,
na?
ah.
So X1 will be common.
Sir, because either one you will take, one will come X1, other will come 1 minus X1, or one will come X2, other will come 1 minus X2.
Ah, so it means it is depending on only one mole, na? Any of the mole fraction.
Yes, sir.
So that is what the point is saying here. Here, what the point they are saying. Total papers over the solution can be related to the mole fraction of any one component. Second point, total vapor pressure over the solution varies linearly with the mole fraction of component 2. With component 2, total vapor pressure is vary linearly. Which component? Component 2. Component 2. With the component 2, it is very linearly. That you keep in mind. Total vapor pressure over the solution vary linearly with the mole fraction of component 2. Now, see here. Depending on the vapor pressure of the pure component 1 and 2, total vapor pressure over the solution decreases on or increases with increase of the mole fraction of component 1. So either it will decrease or increase depending on the mole fraction. Mole fraction increasing means it is increasing. Mole fraction decreasing means vapor pressure is decreasing. Now let us see the graph. It is important graph sometime. A plot between P1 and P2 versus the mole fraction of x1, x2 for a solution given linear plot. These slice 1 and 2 pass through the point for x1 and x2 are equal to unity. Similarly, the plot line third, total vapor pressure x2 is also linear. The minimum value of P total is P1 naught and the maximum value is P2, assuming the component 1 is less volatile, assuming component 1 is less volatile than the component 2. Now, the composition of vapor phase in equilibrium solution determine the partial. That you leave it. Here because here too much theory they have given, you might get confused here. I am compiling and I am telling you. Can you erase this one? What you wrote here?
This is not going, sir. I tried. Not going.
What you are writing that is not going.
No, sir.
Here, this green color one.
Talking about
But
that only.
it should go. It should try once. Try once.
So now also trying, sir. When I'm pressing the also
Okay,
nothing.
no problem, no problem. See, x1 plus x2 equal to 1. x1 plus x2 is equal to 1. That you keep in mind. So when if suppose if x1 is equal to 1, then x2 equal to 0. If x2 equal to 1, then x1 equal to 0. Can you understand this point? Because total is the 1. So if you 1 is considered to be 1, so other may automatically will become 0.
Yes.
Now they are saying that is vapor pressure is linearly valid to the mole fraction of second component. Second component is the solvent. So here is x1, you see x1 is equal to 1. So here x1 is equal to 1. So x2 is equal to going to be 0. And here x2 is equal to 1. So x1 equal to 0. Here you see this one. This is NCERT book only. X1 equal to 1. So x2 is equal to 0. X1 equal to 0. So x2 is equal to 1. Now see the vapor pressure. How it is. When the mole fraction increases, x2 mole fraction increasing now. So vapor pressure
Yes.
is P2 proportional to x2. Yes or no?
P2 is
So P2 partial pressure of the second component is proportional to mole fraction of second component. So as this one mole fraction increasing here, so this line is also increasing. So this line is representing partial pressure of 2. Now, if you talk about the x1, this side x1 is increasing. So vapor pressure of one component here is increasing. This one. This one. So this is going to be P1. Now they are saying you add this one, this two. So this two, if you are adding, so what will be there? P total is equal to P1 plus P2. This is the vapor pressure. This is the P1 naught and this is the what? P2 naught. Pure state. Pure state means highest vapor pressure. So P2 naught will be highest here because mole fraction of two component X2 is highest here. And here is P1 naught will be highest because mole fraction of 1 is the highest here. Can you correlate this one?
Yes, sir.
Okay. Now go back the slides here. You see the plot of vapor pressure and mole fraction of ideal solution at constant temperature. The dash line 1 and 2 represent partial pressure of component. It can be seen from the plot P1 and P2 directly proportional to X1 and X2. Yes or no?
Yes.
Respectively, the total vapor pressure given by mark line third. Third line is where is the third line? This is the first line, second line, third line. Okay. Now, for the vapor pressure, if you are writing vapor pressure, in which form we are going vapor pressure of solid and a gaseous state. Vapor pressure in gas phase. In gas phase. Vapor pressure in gas phase. In gas phase. Okay, gas phase. Gas phase is different case. Vapor pressure in gas phase. So what the depending on P1 is equal to Y1 into P total. This is derived from the Dalton's law of partial pressure that I am not going now. Okay. 1 and 2 respectively, if 1 and 2 are in the vapor phase. Which phase? Are in
Vapor.
vapor phase. Both are in vapor phase. Then using Dalton's law of partial pressure, this equation you know. P1 is equal to Y1 P total and P2 is equal to Y2 P total. This you have to keep in mind. Okay. This
What is
is
the Y here?
why this is mole fraction in vapor phase. Mole fraction in vapor phase. Mole fraction of second component in vapor phase. Components in vapor phase. So in case of second vapor phase, if both component are in vapor phase, then we use this formula. Getting?
Yes, sir.
Okay. Now let us try to some problems. Let us go. On the basis of this one, Raoult's law. So Raoult's law already we study na. Raoult's law what we study P total. Either you write for two volatile component volatile component means what Sanoy? That is liquids. Liquid component. Okay. So they are saying partial pressure proportional to what? Can you tell me? Proportional to its mole
One.
fraction. Mole fraction in solution. Its mole fraction in solution. Okay. Mole fraction in solution. So they are saying for component 1. For component, which component we are going? 1. So P1 equal to P1 proportional to X1. So P1 is equal to P1 not X1. This is equation 2. For component 2. For component what's on a 2. So P2 proportional to X2. So P2 is equal to P2 not X2. Equation 2. Okay. But we know from Dalton's law. From Dalton's law. Dalton's law, sum of partial pressure equal to total pressure. P total is equal to P1 plus P2. So P1 PT is equal to what will be there? P1 not X1 plus P2 not X2. Can you see this one? So now?
Yes. Yes, sir.
Okay. Now see. x1 plus x2 is equal to 1. So x1 is equal to, we can write 1 minus x2. So P2 is equal to P1 naught x1 plus P2 naught x2. So here we are putting that is P1 naught 1 minus x2 plus P2 naught x2. So what will be there? P1 naught minus P1 naught x2 plus P2 naught x2. Positive terms we are taking first. P1 naught plus P2 naught x2 minus P1 naught x2. We can take something, we can take common. So what we can take common? So P2 naught minus P1 naught. Outside it will be x2. This is PT. So what happens? Total vapor pressure is linearly related to mole fraction of second component or any of the component. Can you
This one only 2 minutes ago.
what?
So we did not do this one, sir, just a few minutes ago.
We have done this now, total, Raoult's
Ah,
law.
okay, done.
Okay. Now, there is the ideal and non-ideal solution. Ideal and non-ideal solution. Non-ideal solution. Okay. Ideal and non-ideal solution. What is ideal and non-ideal solution, student? Here, first one I am writing ideal. Second one, non-ideal. Non-ideal. Okay. What is ideal and non-ideal, Sanoy? Have you heard about this one? First one.
No.
It follows Raoult's law. It follows Raoult's law over entire range of concentration. And it does not follow Raoult's law. Getting? Second point. Here is A interaction is equal to B interaction is equal to AB interaction. Okay. Here is A interaction not equal to BB interaction not equal to AB interaction. This is the solute. This is solvent. This is solvent. So there is the interaction if the same. So it is going to form the ideal solution. If it is not same, it is not going to form the ideal solution. Okay. Vapor
Yes.
pressure, vapor pressure, vapor pressure, vapor pressure is same as what? Vapor pressure is same as expected from Raoult's law. Expected from Raoult's law. Raoult's, Raoult's law. Here is next one, third one. Vapor pressure, Vp is not same as expected from Raoult's law. Expected from Raoult's law. From Raoult's law. Raoult's law. Okay. Fourth point. If you are saying delta H mixing, no energy will release. Delta V mixing, nothing will happen, no change in volume. But here in the other case, if you are going non-ideal solution, so delta H mixing, it never be zero. And delta V mixing, it never be zero. It can be more or less. Check here. Can you understand this one?
Yes, sir.
Ideal, sometime roughly I write. Is it okay?
Ah, I
Okay.
didn't.
Okay, so let us try to see some of the question here. Here saying vapor pressure of liquid solution. What is vapor pressure of liquid solution?
Sir, the vapor particle exerting the force or exerting the pressure on the surface of liquid.
Hmm. So that is here see. In term of liquid solution, they are asking in term of liquid solution, binary solution. So here saying a solute dissolved in liquid solvent result in the formation of liquid solution. A solution containing one solute and one solvent is known as binary solution. Now see, this is here, see. Question they ask in the many type in the exam, they are asking, state the Raoult's law for containing volatile liquid.
Sir, I saw that you sent me the syllabus of chemistry for NEET. So the same way, can you send the physics and biology also if you have them?
Okay,
Because my
okay. I will download and I will say. So this is the derived Raoult's law. Here, I will do. Don't worry. I will do. Can you understand? Derive the Raoult's law. Can you derive the Raoult's law?
yes, sir.
Sure.
Yes, sir.
Okay. If you are saying, then you derive the Raoult's law here. Derive, derive Raoult's law, Raoult's law for two volatile liquid. Okay. Or liquid solution. Liquid solution. Okay. Derive. Are you doing?
Yes, sir.
Hmm.
Sir, visible what I'm writing?
Not visible. Nothing is visible. Now visible. Now visible. Are you doing?
One thing, sir, just one time. So let's take so much time. So like this for
Keep on doing.
volatile for two volatile.
Hmm. How you are writing this one? For you are writing the typing or what?
Yes, sir.
Don't
Two
type.
volatile.
Don't type. It will take time. Directly you do. As you handwriting is not
It's
important.
taking a lot of time, sir. I don't know what is the problem, sir. Not I'm not able to write here.
Uh,
Not writing.
so leave it
No,
then.
no, no, now working, now working. Now.
Okay.
Components,
Hmm.
liquid.
Hmm.
So visible now what I'm writing?
Yeah. 100%, 100%.
The partial pressure.
Hmm. You just derive. You just derive. Don't write much. Just derive.
So I was writing the statement also.
Not required. Just you derive.
Yeah, where is it now? From P1.
Hmm.
Ah, P1, P2, P1, and P2.
Okay. Good.
After this P1 and P2, I know that's good. P1. P1, 1 minus x2.
Okay. Okay. Great.
That's okay.
Okay, super. Now come back to the topic now. Questions we are doing. So derivation you did. Okay, the first question is over. So this one is here you see.
Okay.
Some conditions are mentioned here. Some little bit more concept are there that we have to conclusion. P total can be related to x2 or x1 that you wrote already. P total varies linearly with x2, mole fraction of second component. P2 not P2 greater than P1. It means P total increases with increase in x2. Why? If P2 not is more, means x2 is more, and P1 is more, means x2 is less. Means x2 is less means x1 is more. Getting?
Okay. Yes.
Okay. Draw and explain the plot vapor pressure versus mole fraction of ideal at constant temperature. How are partial pressure of the component related to mole fraction in vapor phase? So this one in the vapor phase, what we write? P A is equal to Y A P total. Yes, yeah, no. And if you are writing PB is equal to YB P total, is it okay?
Yes, sir.
Second one, draw and explain the plot of the vapor pressure and versus mole fraction. So how we were diagrammatically we were doing this one. So if I will consider these two line we are considering, what are the line we are considering?
Like
This
this.
is the vapor pressure. No. So if you are considering this one, so P2 should be more, na? Which one is P2 then?
So this
Which
one
one?
P2, this one P2, this one P1.
So here you need to write P2 not.
Um,
And this one is P1 not. So mole fraction here, which one will be high and which one will be low? What we will
Sir,
write?
P2
X1.
will be high and P1 will be low.
So here is X1 will be 0. X2 will be 1. Here is X1 will be 1, X2 will be 0. Are you getting this?
Yes, sir.
Okay. So you can see here this one NCRT one. P1, P2. This one is there. So this
Hmm.
is there. So I think you understood this one. This one vapor pressure also in this case. Now, another question is there. Raoult's law as a special case of Henry law. This question asked in many time in the CBSE board exam. So see, Henry law. No, Henry law. How Henry law see? PA is equal to KHA or XA. This is there. Now, if you are going for the Raoult's law, here we are writing Raoult's law. Raoult's law. So Raoult's law PA is equal to what is P naught A X A. So only different is what is there. That is KH become equal to P naught A. KHA become. That is in Henry law, Henry Henry constant becomes equal to vapor pressure in pure state. Vapor pressure of component components components in pure state. Are you getting? Only this is different. So here this one is the Raoult's law and this is Henry law. So both you read here what they are saying. In here. Let us compare the equation 1 Raoult's law, equation 2 Henry law. It can be seen that partial pressure of volatile component or gas is directly to its mole fraction of solution in a special case when KH become equal to P1 naught. Raoult's law become equal to Henry constant. Henry law. Raoult's law become to Henry law. If you are putting KH equal to P1 naught. Are you getting this?
Hmm.
Okay. Vapor pressure of solution of solid in liquid. Solid in liquid. So can we continue? Okay, let us do some of the problem here.
স্কুল স্যার কোন বই এটা আমাকে ইনসিয়ার থেকে কোন আমি কি করে ফলো করব এই বইটা
Here.
sir, from what book you are teaching this one, sir? I don't know, sir. If you teach from NCERT, that would be better because sir, I
That
have
is
the NCERT.
that is NCRT only. That is NCRT.
Sir, not this one, sir. The previous one.
So previous one is the question. Question where you will get the question? Previous year questions. This is board question. See CBSE 2012.
Sir, but which book is this, sir? I do not have this book.
Book is not required, na. This is the answer is from NCRT only, na. Book, what you will do with the book? Like ideal and non-ideal solution, you see how many type you can. I am giving some idea that is this will come. 2015 it came, na. So it is important. So same
Uh,
whatever there in NCRT, go back to here NCRT. These are what is there. Here little bit you go down. Just you see ideal and non-ideal they are here. Can you see this one?
yes.
So everything is NCRT only. Just I taken in the different form. Hmm. Are you facing problem or what?
No, no,
It
nothing.
is NCRT only. Total. I just this is full page is taking now. I just compiled. I make it half. That much only. Hmm. So this is I am giving you one question. Ideal solution. Here you see. Let me take the problem. Here question is there. Hmm. This question is there. 2.8. This question. 2.8. Or you can solve one more question. Here is already solved question. This one. Here the question is there. What they are saying, vapor pressure of chloroform and dichloroethane, this is at 298 Kelvin are 200 mmHg and 415 mmHg respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of CH2Cl2 at 298 Kelvin. Also, they are asking mole fraction of each component in vapor phase, but that you do later on. Firstly, they are asking calculate the vapor pressure of the solution that they are asking. So how we calculate vapor pressure of solution? P total is equal to P1 naught X1 plus P2 naught X2. This formula you already know? Yes or no?
Yes.
So by using this formula, you can solve this question. So what I am doing, I am taking another slides because it is difficult. It is difficult to get the question from here. Cancel. Because place is not there now. Leave. Wait. So, there or not. Give me one. Leave. Okay, so now you are having the book now in front of you.
Yes.
Okay. So this question I am solving on another page. Go back here because otherwise I need to take the PDF. So you tell me that is PT is equal to P1 naught X1 plus P2 naught X2. So for this one is for chloroform. This one is for chloroform. Chloroform. And second one is this is for CH2Cl2. These two component are there, right? Yes, yeah, no. Now this one P1 not they have given. P1 not they have given. P1 not for chloroform. Can you tell me what is P1 not for chloroform? How much they have given? Hmm?
The
Chloroform
vapor to 20,
pressure
200
200
mmHg.
200 mmHg. This is for chloroform or dichloroethane?
Chloroform, sir, and dichloroethane is 450.
Okay, 415. And what is mole fraction? How to calculate, Sanoy? That is N2 upon N1 plus N2. Here what will be there? N1, N1 plus N2. This is the what is there? CHCl3. This is CH2Cl2. Now check back. 200 multiply by. How can we do? Given mass over molar mass. This is again given mass over molar mass plus given mass over molar mass plus 415 multiply by this is given mass over molar mass, then again given mass upon molar mass plus given mass over molar mass. Now, here is 200. Now, can you tell me the given mass of the chloroform?
Given mass of chloroform
Gram mass, they have given.
25.5 gram.
Don't tell mistake, na?
So 25,
25.5.
I told 25.5.
25.5. So 25.5. Molar mass of chloroform is 119.5. We have done earlier CHCl3 12 plus 1 plus 35.5 multiplied by 3. So this is 13 plus 3 5 ja 15, 3 5 ja 15, 1 16, 3 3 ja 9, 1 10. So if you add this 1.5, 639, okay, 639 only. And here is 119. And CH2Cl2, 12 plus 2 plus 71. So what will be 14 plus 71? How much will be there? 85. Okay. So here plus 415 multiply by given mass of the dichloromethane. Can you tell me?
Sir, given us the dichloromethane is 40 gram. 40 gram.
40 gram. 40 upon 85 divided by, here also something is missing here. 25.5 upon 119.5 plus what will be there again 40 upon 85. You can separately you can solve also, there is no problem here. I am doing little bit the compiled one plus 40 upon 85. Okay. Now this is the calculation portion. Only two required to solve, remaining will be the same. Okay, all remaining will be same. So here is 200. Now I am doing the calculation portion. You kindly see this one. Wait 1 second. Let me find out the 25.5. We are writing 25.5 divided by how much? 119.5. It is coming somewhere how much? 0.213 divided by 0.213 plus 40 by 85. 40 by 85. It is how much is coming? 0.47. Similarly, now no need to multiply anything. This will be 0.47 divided by 0.213 plus 0.47. Now we are solving this one here. 200 multiplied by 0.213 divided by, if you add this one, 0.213. So here it is coming 0.683 plus 415 into 0.47 divided by 0.683. Calculation is very heavy in this case, in all the cases. 200 multiply by, if you are going 0.213 divided by 0.683, 683. So it is
The
coming
board is
somewhere.
the calculator or not? Same board or need?
No, they will not give, but it is 3 mark question now. So 3 mark question will always be this time, but this time very easy came. I am showing you the question paper now this year. Okay, 0.4. The question came on this topic only, 2 mark question, but it will take 1 minute only. 683. So it is the 285. This is the 285.5. Now you can add on this one. It is going to be 62.3. 347. 347.8 mmHg. Now can you check your answer? P total is came. This is 3 mark question. How much is coming answer? 347.8. Now, if you cannot check, I am going to check, show you. See here the answer. How much is? 347.9. Can you check?
Yes, sir, checked already.
Okay. Now they are saying that is you need to calculate vapor phase, mole fraction in vapor phase. So that we are going to do now the same one, that is the mole fraction in vapor phase. So P total is there here. So what I am doing, I'm calculating here because I'm not going to the next page. Similarly, I'm calculating here. So if you are calculating P, what is there? CHCl3. So what will be there? PT, right? Plus YCHCl3. So YCHCl3 is equal to PCHCl3 upon PT. PCHCl3, how much is there? Here, if you solve this one, 62.3, this one coming. So, getting this one,
Yes, sir.
PCHCl3, this is there. So, 62.3 upon 347.8. Okay. So, let me solve. 62.3 divided by 347.8. So, you can check the answer, Sanoy. This is 179. YCHCl3 0.179 is there or not? Can you check?
Yes. Says still the
YCH2Cl2. So PCH2Cl2 upon PT. So PCH2Cl2 here 285.5. 285.5 divided by 347.8. So if I will 285.5 divided by 347.8. So it is coming 0.820 YCH2Cl2. So one is 0.179, another is 0.820. Now let us check back the answers here in the book. What is there? 0.82, 0.17. Is it correct or not?
Yes, sir.
Sure, understood.
Huh.
Okay. Can I give the question? Will you try?
Yes. Yes.
Do you have time or you want to take rest?
No, sir. Yeah.
Okay, this problem you do, then you can take rest. Okay. Wait,
This
I
one.
will. Wait. What I'm doing, I am giving you the fresh one because here no place to write now. So how can you write this one? I have taken that one many questions I am having on the basis of this one Raoult's law. You try to solve that problem. Just you give me 1 minute. Initially, you will find little bit difficulty, right, to solve the problem. After that, it will be all will be very easy. This problem initially calculation here also you must be finding little bit difficult now because I am doing the all the step all together. You can do the separately also, so it will become very easy, interesting. Today I share you the previous year question. Have you seen this one?
Sir, I've seen that you shared something, but I did
Uh,
not check it.
no, last year question. This year board exam question paper is that. This question number is suppose
Sir,
4.
so this year's question.
So question number 18 is there. Question number 18. Based on the same one. Question number 18.
Non-volatile solution. These are 200 gram H2.
That I will do now. Just you firstly you do this one. That I have taken now. Now you can use this one. Very same question. Can you see? Same question. The vapor pressure of your liquid A, B, this one is there respectively at this one. Find the composition of liquid mixture if total vapor pressure is 600 mmHg. Also find the composition in vapor phase. A and B are this one respectively. Find out the composition of liquid mixture. If you cannot solve here because the amount is not given. Okay, it means I need to solve this one. You leave it. Okay. Composition they are asking, composition. So you cannot solve out. This is the type 2 type problem. You see second one. Wait. Solution. So now I given you the paper. Can you guess this one? This is not.
Unfortunately, question.
Question number 18, you check. Question number 18. Can you check question number 18?
Okay. This one, sir, which compound in the given, now 18 gram of a non-volatile solution dissolved in 200 gram of H2O, freezes at 272.07 Kelvin. Calculate the molecular mass of the solute.
This is this year question paper. Question number 18. Acha. This is also second type question. Don't do this one. Okay. Don't do this one. If you want to try at home. Now it is the 11:30. I'm going for the dinner. Okay. Problems are there in NCRT. You try to that one. Raoult's law problem will be there in the NCRT.
Okay.
Exercise, you
Okay.
search the exercise and example, you will find the problems. So there you solve the problem. Tomorrow I will inform you what time I will take the class. Now.
And sir, you please send me the physics and biology syllabus.
Oh, that I need to download. Yeah. After the dinner, I will send.